Welcome once again to our discussion on principles of economics, and we were discussing about market structure. In our previous class, we were talking about monopolistically competitive market structure and the pricing and output decision of the firm, short run and long run equilibrium, so on and so forth. Now, we said that monopolistically competitive market is basically characterized by a large number of small firms, and products are almost identical, but they are not similar. So, there is scope for product differentiation. Now, there is one more type of market that is also called as imperfectly competitive market, which is called oligopoly. And how do you differentiate this market with the monopolistically competitive one? Here in oligopoly, you have small number of large firms. Now, when you have very small number of large firms, let us say either 4, 5 or 6 firms that constitute the entire industry, then each firm can actually observe the strategies or decision making about the pricing, advertisement, output, everything of the other firm. So, that means the situation becomes strategic in nature. So, a particular firm cannot unilaterally make the maximum profit without considering the competitors' strategy, right. So, in a strategic situation, how to play your action, how to take your actions that will maximize your profit, it depends on how best you can understand the strategies of the other firms or your competitor. That is why to analyze the firm behavior in oligopoly, we need to understand a concept, certain tools developed by mathematicians which are known as game theory. Why game theory? Because this oligopoly market is a strategic decision making situation where firms behavior are called strategic behavior. Firms, they take their decision based on or anticipating what the others or rivals may react. Okay. So, I can give you an example of this type of market. Let us say telecom industry or telecom market. There are only very few number of players. You have Airtel, you have Idea, you have BSNL, you have Reliance, and probably you have Reliance Jio nowadays. So, only 4 to 5 players that are dominating in the industry. In that case, while taking any decision about the pricing of the product, let us say Reliance is thinking whether to go for this offer or not. Reliance is thinking, if I go for this type of strategy, how my rivals are going to react. So, my payoff or the realization of my profit would therefore depend on understanding my rival's strategy. Without understanding or without considering their strategy while making my decision will lead to a situation wherein I won't be able to realize my profit. That is why to take my best decision, I need to consider what are the best responses available to my rivals, and that I need to consider using a particular theory called game theory, which was pioneered by the two famous mathematicians John von Neumann and Morgenstern, Oscar Morgenstern in 1944. And in a game theory, there are 4 important elements. They are called players, actions, payoffs, and information. Players are actually individuals who make decisions. In this context, we can say the players are the firms. Actions means a choice. which is available to the firm. That means it can be a choice of advertising, it can be a choice of pricing, it can be a choice of designing new products, so on and so forth. Payoffs is the utility or profit that the players receive when each player they take their action. So, when all the players they have taken their decision, let us say about advertising, what is the profit that a particular firm earns, that is called the payoffs for that particular firm. And information, which is knowledge about other players action. These elements, these players action, payoff and information, they define the rules of the game. And we assume the information is perfect or knowledge is common in this particular case. And how do you define common knowledge? When there is a P, there is a common knowledge P in a group of agents G, when all the agents in G know P. Okay? And they all know that they know P, they all know that they all know that they know P, and so on ad infinitum. So, that means if you extend that loop, for example, if there are two players you and me, I know what is the strategy that you are having, you also know what is the strategy that I am having, and I am not extending in a second round. That means I know that you know what is available to me. Again, if I extend, I know that you know that what I am having. So, it will add up to an infinite loops. So, that is called common knowledge. Okay? And then we also use the concept of equilibrium, which is a set of best responses of each player, and that equilibrium may or may not be unique. In a particular game, there might be an unique equilibrium, there are also possibilities of multiple equilibria, right. So, these are the important elements of a game. There are basically two types of game. One is called cooperative game, in which the joint action agreements are enforceable. That means, the players they cooperate and take a joint decision to maximize their joint profit. Non-cooperative games, in which the actions players they take their action based on their own interest and try to maximize their own profit or payoff. And that non-cooperative game is again of two types: simultaneous move, that means when all the players are taking their decision simultaneously; sequential move, that means a particular player can observe what her rival is taking, based on that the other player takes his or her decision or action. Then we have dominant strategy. A strategy is dominant if it is optimal or best, regardless of whatever my competitor does. For example, if there are two strategies or options available, advertising or do not advertising, and if it so happens that irrespective of what other firm does, advertisement is always better for a particular firm, then we say that advertising is a dominant strategy for a particular firm. So, dominant strategy means a best strategy irrespective of what other does. And an equilibrium consisting of dominant strategies, they are known as dominant strategy equilibrium. So, dominant strategies always provide best outcome no matter what decision rivals make. And then when dominant strategies exist, the rational decision maker always follows its dominant strategy, and then predict rivals will follow their dominant strategies if they exist. and then ultimately we get a dominant strategy equilibrium, wherein both the players are having dominant strategy and they are playing also. So, dominant strategy equilibrium exists when all decision makers have dominant strategies. Now, here is an example. Let us say that there are two players, firm A and firm B. They have two strategies, whether to go for advertisement or do not go for advertisement. Within the bracket, you see there are two numbers. First number is the payoff or the profit of the first player. First player is firm A, which is measured in the left side of the payoff matrix. This is called payoff matrix, consisting of payoffs of all the players are known as payoff matrix. And then you have firm B, which is known as the second player. So, that means when both the players are taking the decision to advertisement, so advertising and advertising, that results in profit 4 for firm A and profit 3 for firm B. Okay. Similarly, if firm A chooses to advertisement and firm B does not, then the profit for firm A is 5, profit for firm B is 1. Now, this is the advertising example. So, firm A and firm B. Now, we have to think whether any of these firms they are having dominant strategies or not. Look at this. Let us first find out the equilibrium. Okay. What is the optimal strategy for firm A, given the fact that firm B chooses to advertise? As I said, this is a strategic situation. So, while deciding about firm's optimal strategy, we have to consider both the strategies available to firm B and then what is best for firm A. So, given the fact that firm B is going for advertisement, now if the firm A goes for advertisement, then the firm A earns 4, and by do not advertise, firm A earns 2. So, obviously, since 4 is greater than 2, I can say that when firm B is going for advertisement, firm A's best response is to also go for advertisement. Look at this. If firm A chooses to advertise, then payoff is 4, otherwise the payoff is 2. So, optimal strategy is advertise. Okay. And then you can use a simple tick mark on top of this, a simple tick to denote the best response of firm A. Now, go to here I will be using the tick again. Go to the second strategy. When the firm B is thinking do not advertise, what is the best strategy? Again advertisement, because by going for advertisement it is 5 and not going for advertisement gives 3 to firm A. So, that means again this is better. So, one thing that means it is clear that irrespective of whatever firm B does, going for advertisement is the best response for firm A. That means I can say that firm A has a dominant strategy in advertisement. Now, same thing we will consider for firm B, considering each and every options available to firm A. So, when the firm A is going for advertisement, if firm B also goes for advertisement, firm B gets 3, otherwise 1. Since 3 is more than 1, 3 is the best response. So, I have given a star to denote the best response of firm B. Similarly, when firm A goes for no advertisement, again advertisement is best for firm B because 5 is greater than 2. That means firm B also has a dominant strategy in advertisement. Therefore, what we can say that both the firms A and B, they have dominant strategy, and their dominant strategy is to go for advertisement. That is why in this particular game there is a possibility that we will get a dominant strategy equilibrium. Okay. So, the dominant strategy equilibrium for firm is that both the firms are going for advertisement, and this is the payoff. Is this clear to you? So, first of all, we need to equilibrium means we need to find out the best response of a particular firm, find out the best responses of both the firms or both the players, considering the best responses of each of the players. So, while deciding about the best response for firm B, we will consider what are the options available to firm A and then which one is giving the maximum payoff. Same way we will consider the other players' best strategies also. Okay. So, this is example 2 again. You can easily solve this. When the firm B is going for advertisement, then firm A, by going advertisement, it is 4, it is 2. So, this is best. When firm B is not going for advertisement, firm A's best response is now do not advertise. So, that means in this case firm A does not have a dominant strategy, because its best response is actually changing depending on what firm B is playing. It is advertisement when firm B goes for advertisement, it is do not advertisement when firm B also going for do not advertisement. Similarly, when firm A is going for advertise is better from firm B. When firm A is going for do not advertise, then advertise is actually is best. So, that means what is happening here, firm B has a dominant strategy in advertisement, but firm A does not. Therefore, in this case the equilibrium is advertise and advertise, because you see this particular cell consists of the tick and star, that means best response of both the players, but we cannot call this as a dominant strategy equilibrium, because this does not consist of dominant strategies of both the players, right. So, they have explained here optimal strategy is advertise, and then when it is do not advertise, best strategy for firm A is also to do not advertise, right, is advertise. The dominant strategy for firm B is to advertise. Okay. So, therefore, the equilibrium is this. Regardless of whatever firm A decides to do, the optimal strategy for firm B is to advertise. Now, we are going to a concept called Nash equilibrium. So, Nash equilibrium shows how selfish competitors should act in relation to those whom they compete against. It deals with individual needs and desire in a group context and must take into account likely human behavior. Now, the concept of equilibrium itself was first introduced by John Nash. Therefore, any equilibrium in game theory is known as Nash equilibrium. There is no other equilibrium than the Nash equilibrium, because the equilibrium concept was first introduced by John Nash, and he basically said that what is Nash equilibrium? Nash equilibrium consists of the best responses. So, my best response is decided based on your best response, and your best response is decided based on my best response. Therefore, in an equilibrium, both the players are having their best responses, and that is the equilibrium concept given by John Nash long back. However, as we have already discussed, a dominant strategy means an equilibrium. A dominant strategy equilibrium means an equilibrium consisting of dominant strategies of both the player. So, we can then say, while all the equilibrium are Nash equilibrium, all Nash equilibrium are not dominant strategy equilibrium. Okay? All dominant strategy equilibrium are Nash also, because the equilibrium concept itself is given by Nash, but all Nash equilibrium are not dominant strategy equilibrium. So, Nash equilibrium is a set of actions or decisions for which all players they choose their best action given the actions they expect their rivals to choose. So, no player regrets his strategy given everyone else's move, and that is why Nash equilibrium is stable. Strategic stability is there with the Nash equilibrium. No single firm can unilaterally make a decision and do better. This is very important, because my best response is decided based on your best response. So, the moment I go to another action thinking that is better, the other firm will also move from that response to the other response, and your payoff cannot be materialized. That is why no firm can unilaterally make a different decision and do better once they arrive at Nash equilibrium. Now, here is one more important concept called prisoner's dilemma. Many a times in many social contexts and its business contexts, we find this type of problem, which is known as prisoner's dilemma. So, first you read this particular story to understand prisoner's dilemma. Please take a minute and read it. So, two suspects are arrested for armed robbery. They are immediately separated into different cells. If convicted, they will get a term of 10 years of imprisonment. However, the evidence is not sufficient to convict them of more than the crime of possessing stolen goods, which carries only a sentence of 1 year, because first of all you need to prove that. So, the suspects are told the following: if you confess and your accomplice doesn't, then you will go free. If you do not confess and your accomplice does, you will get 10 years of imprisonment. If both of you confess, you will both get 5 years of imprisonment. This is the story. Can you construct a payoff matrix based on this particular story? Player 1 and player 2, what are the strategies they have? Either confess or do not confess. And when both of them are confessing, what is happening? They will get a sentence of 5 years of imprisonment. When both of them they are not confessing, they will get only 1 year of imprisonment. So, this is the payoff structure. Both of them are confessing 5 and 5, both of them do not confessing 1 and 1. Now, let us see what is the equilibrium of this particular game. Given that individual B is going for confess, do not confess is the, this is basically imprisonment. So, 5 is better than 10. Look at these payoffs are negative payoff you can think of, because this is imprisonment, you have to spend that much time in prison. When firm B is confessing, individual B is confessing, for individual A, confess is better because it is only 5 years of imprisonment. Otherwise, by do not confess, they will firm A or individual A will get 10 years of imprisonment. Similarly, if the individual B do not confess, again confess is better because 0 is greater than -1. That means what we can say, that irrespective of whatever individual B does, confess is the best response for individual A. Therefore, individual A has a dominant strategy in confessing. Similarly, when individual A goes for confess, confess is better for individual B also, because otherwise individual B will get 10 years of imprisonment. Okay. When individual A is going for do not confess, still confess is best for B, because otherwise B will get 1 year of imprisonment. So, that means individual B is also having a dominant strategy, which is confess. Therefore, both individual A and B are having a dominant strategy in confessing. And what we have learned earlier, if both of them are having dominant strategies, then they will definitely play their dominant strategy and we will get a dominant strategy equilibrium, which is confess and confess here. Now, look at the interesting part of this story. What is happening in this game? Had they cooperated, had they not confessed, they would have both got only 1 year of imprisonment. That means, do not confess and do not confess is actually optimal for them, but still they are not able to arrive at that optimality. This is optimal. But they are not able to arrive at that optimality because they have dominant strategy in confess, that means non-cooperation. So, this particular game has two important features. Both of them are having dominant strategy, both have dominant strategy, and then secondly, the dominant strategy is in non-cooperation. Non-cooperation means I am not cooperating with my friend by sticking to non-confess. I am thinking, let me confess and get out of this prison. My friend is also thinking in the same line, and therefore, this dominant strategy equilibrium is actually Pareto suboptimal. So, this is called, this equilibrium is actually a suboptimal situation, because there is a better options available, but still that is not materialized because the individuals are not cooperating. And if a particular game has these three features, then we call that particular game as prisoner's dilemma. So, prisoner's dilemma must have three features. Both the players should have dominant strategy should be in non-cooperation, and dominant strategy equilibrium is Pareto suboptimal. So, that is the thing they are explaining. Dominant strategy, both individual confess, and that is the Nash equilibrium. We have proved that. Now, look at this context. Firm A and firm B, there are two options, low price or high price. Okay. Then the question is this a situation of prisoner's dilemma or not? So, first of all, we must check both the players must have a dominant strategy. Okay. Look at this, when firm B goes for low price is best for firm A because 2 is greater than 1. When firm B is go for high price, again low price is best for firm A because 5 is greater than 3. So, irrespective of whatever firm B does, low price is better for firm A. Therefore, we can say that the firm A has a dominant strategy in low price. Similarly, when firm A goes for low price, what is the best response for firm B? It is again low price because 2 is greater than 1. When firm A goes for high price, then firm B still has the best response in low price. So, that means firm A and B both are having dominant strategy in low price, and that low price, the dominant strategy equilibrium is suboptimal. Look, this is the optimal, this is optimal. Both of them could have achieved a profit of 3 units each, but they are earning only 2 units each. So, they are arriving at a suboptimal situation. Why this is happening? Because each firm has a dominant strategy in cheating, non-cooperation. Firm A is thinking, if the firm B goes for low price, I must charge low price because otherwise no one will buy my product. When firm B is going for high price, firm A is thinking, let me charge low price and steal the market share from firm B. Had they cooperated in high price, that is called collusion, which is a behavior in oligopoly market. Many times the firms can collude and act like a monopolist. Even though there are more number of firms, they can come together and collude and arrive at a situation which is called collusive oligopoly and enjoy this optimal profit. But difficult to arrive at this situation because everyone believes in dominant strategy, which is non-cooperation. So, all the three properties are fulfilled in this particular game. Both the firms are having dominant strategy is in non-cooperation, and dominant strategy equilibrium is Pareto suboptimal. Optimal is here. So, dominant strategy is low price, and here again another example of non-price competition, which is advertisement. Again dominant strategy is advertising and both of them they end up with a profit of 2 units each, while they could have enjoyed 3 and 3. Okay. So, do not advertise is actually a best response for farm for both the players, but they are not able to enjoy that because they have dominant strategy in non-cooperation. Okay. So, this is again another example of prisoner's dilemma. So, this is cartel cheating, that means cartel means again collusion. So, if both the firms they collude and form a cartel, then they can act as a monopolist by charging high price, and then they can equally share the profit, but they are cheating each other. Firm A is thinking, let me charge a little lower price and grab the entire market. Firm B is also thinking, let me charge a lower price than firm A and grab the entire market. In doing so, they are actually charging both of them low price, and they are ended up with cheating and cheating. That means they are getting only 2 and 2. So, dominant strategy is to cheat, and therefore, this is also a prisoner's dilemma. Now, is there any solution to this prisoner's dilemma? Look, here the game what we are discussing is only one shot game. So, that means one period game. What will happen if the game repeats for multiple rounds? So, then there is a possibility of getting cooperation. So, in repeated games, many consecutive moves and counter moves by each player, then actually there is a tit for stat strategy. That means, if your opponent does not cooperate with you, then you can always punish him or her by not cooperating. So, do to your opponent what your opponent has done to you, that is for tit for stat strategy. And that tit for stat strategy, that's punishment, if you can give, then actually you can solve the prisoner's dilemma. But for that, these are the conditions required. You should have a stable set of players. The number of players should not change. You should have small number of players, that is the characteristics of a oligopoly market itself. Easy detection of cheating, we should be able to know who is actually breaking the law, who is cheating. Then there is stable demand and condition. Game should be repeated to a large and uncertain number of times. This is again very important. Why I am saying? The game should be repeated, because if it is one shot, each player is thinking that let me cheat and get out of this context itself by grabbing the entire market. For example, when you travel by train and buy biryani from your station, then the biryani seller has an incentive to sell bad quality biryani, thinking that in future there might not be any interaction with you. But if the case is so happen that there is repeated interaction, then the seller has very less incentive to cheat you. Therefore, even in market also, if you buy your product from the same sellers every day, so that means repeated interaction, sellers cannot cheat you. If they cheat, next time you won't come to him. That gives an incentive to not to cheat. Both you as a buyer and the seller are better off. But the game should be repeated for an uncertain number of time. If the players they know the game is to be repeated only for, let us say, 9 times, then each player will try to cheat at 8th period. Then following the rule of backward induction, then there will be cheating in 7th, 6th, 5th, 4th, 3 and 1. So, uncertain number of times the game should repeat, otherwise we won't be able to get tit for tat strategy. Okay? And then this threat strategy should be credible, reputation, and then there should be entry deterrence. Okay. An example is entry deterrence. These are extension of the game theory whatever we have discussed. Okay. So, this is a game with threat, right. How the threat is giving? Let us say firm A is giving a threat to firm B. If you charge for low price, I will punish you by low price. Now, the question is it a credible threat? How do you measure credible threat? First of all, the player should have that capacity, and by doing so it should be generate better payoff for firm A, then only other players will believe that this is a credible threat. Look at here, when firm B is going for low price, firm A is saying if you go for low price, I will also go for low price, but is it a credible threat? No, because by going to high price, this is better for firm A. So, that means the threat, even if firm B A gives, that is not a credible threat. Okay. Firm B won't believe that. But let us say firm B is giving a threat, if you charge low price, I will also charge low price. Is it a credible threat? See, low means when firm A is going for low, 2 is greater than 1, so it can go for low. If the firm A is going for high, then 4 is greater than 3, again low, right. So, that means while the firm B can give a credible threat, firm A cannot, and this is a payoff matrix without credible entry deterrence. Look at this. So, what is happening here? What is the equilibrium? If both the firms are having, let us say firm A is having two strategies, low price and high price, and there is a credible entry threat from firm B. Now, the question is this a credible entry deterrence? So, that means we need to think that the entry deterrence faced by B is credible or not. When the firm B decides to enter, the firm A can go for either low price or high price. Charging high price is better. When the firm B decides do not enter, then again charging high price is better for firm A. So, that means I can say that whether I am entering or do not entering, it does not matter for firm B, firm A. So, that means this is not a credible entry deterrence. Firm B's entry does not make any difference in firm A's action. When firm A is thinking of low price, by entering, firm B will get -2, by do not entering will get 0, this is better. When firm A charges high price, by entering will get 2, by do not entering 0, this is better. So, that means the firm B's entry decision depends on what firm A does. So, there is no dominant strategy in entry. Equilibrium is high price and firm B will enter, but this entry deterrence is not credible for firm A. Okay? There is no entry threat, right. but this is a credible entry deterrence, right. What is happening? Look at this. If firm A charges for low price, then if firm B tries to enter, then -2 by do not enter 0. If the firm A is charging high price, then it is again entry is better. Similarly, when firm B is trying to enter, then low price is better. When firm B is do not enter, then high price is better. So, that means by firm A's decision whether to charge low price or high price, it depends on what the firm B is playing, whether entering or not entering. That means there is a credible entry threat. Okay. So, entry deterrence is explained here. No credible entry deterrence, here is a credible entry deterrence. Look at this. This is again two firm competition and strategic trade policy, produce or do not produce. Okay. International competition, and now we have a case of sequential games. So, that means the other player decides whether to what decision to take, that depends on what the other player has taken initially. So, that means sequence of moves by the rivals, and payoff depends on the entire sequence. Okay. I will give you an example. Look at this. Firm A has two choices, high price and low price, and depending on what firm A does, firm B can then observe firm's behavior and decide whether to go for high price or low price. So, in this game, the solution, how will you determine? When you have a sequential game, what you do? You divide the entire game into two parts, upper section and lower section. So, let us say that firm A decides to go for high price, right. Then if the firm B goes for high price, then firm A will get 100. If firm B goes for low price, then firm A will get 130. So, that means depending on firm B's decision, firm A should go for high price here. Okay. So, firm A is thinking whether to go for high price or low price. By going high, firm A, how firm A is thinking that if I go for high price, what firm B will do? By going high price, firm B will get 100. By going low price, firm B will get 50. That means firm B will definitely play high price, and in that case my payoff would be 100 from the upper subsection. Similarly, for the lower subsection, firm A is thinking if I go for low price, then firm B can go for high price, that will fetch him 80, but going low price firm B will get 120. That means definitely firm B will go for 120. In that case my payoff would be 150. Okay. Now, firm A is comparing the payoffs from the upper subsection and the lower subsection of the game tree. That means comparing 100 and 150, 150 is better. So, that means firm A will definitely go for low price, and if firm A goes for low price, what is best for firm B? Will definitely go for low price, because that gives firm B 120. Okay. So, this low and low, this is the equilibrium, this low and low, and this is called sub game perfect Nash equilibrium, SPNE. This is happening in a sequential move game. Okay. This is how you have to solve. You have to divide the entire game tree. I will repeat once again. Divide the game into upper and lower sub game. Then you see what should be the form A's strategy, best response from the upper, best response from the lower, depending on the form B's decision, and then form A will compare his payoff from the upper and lower sub game to select the best response. Form A is thinking, if I go for high price, form B would react with either high or low, giving him 150. That means the moment I go for high price, form B will definitely react with high price, which will give me $100 payoff. Similarly, if I go for low price, firm B will definitely react with low price, because that is giving him 120, and in that case my payoff would be 150. So, by going high my payoff is 100, by going low my payoff is 150. So, obviously firm A will go for low price and firm B will also react with low price. Then low and low is the equilibrium. Okay. So, that is called sub-game perfect Nash equilibrium. Now, in this case, by moving first, firm A is earning 150 rupees. You can reverse this game considering, let us say firm B is moving first. What should be the A's payoff? If you can prove that by moving first, firm A's payoff is more than what the firm A earns while moving second, then you can prove that in this game firm A has a first mover advantage. What I am saying? First mover advantage. So, moving first will give you more payoff than moving second. So, how will you prove with this example? In this case, firm A is moving first, and what is the payoff? 150. Now, you assume firm B is moving first and then structure the game. Calculate the equilibrium payoff for firm A while moving second. Compare these two. If you prove that moving first gives more payoff to firm A, then we can assume, we can tell that in this game there is a first mover advantage. Otherwise, there would be a second mover advantage. So, high price low price game, high low, how we were explaining, they have divided into two, high price low price. Look at this. When firm A is going for high, then going for low is only 50, that is why this is cancelled. Firm B will get definitely react with high, and in that case by going high this is also 120. Okay. So, this is the both firm chooses low price, the exactly same thing what I have explained. Okay. First you have to select firm B's best response from the upper and lower sub game, that is what they are doing. This is again the same thing with Jumbo Jet and Sonic. Okay, I am not going to repeat this once again, the same logic. Okay. So, if firm A goes for A380, then for firm B it is better to go for Sonic Cruiser because 100 is better than 50, and in that case firm A will get 120. And here look at here, when it is this, then firm B will react with 200, and in that case it is 0. So that means now I have to compare this 0 with 120. Obviously, then this is the equilibrium. Okay. Always provide best outcome no matter what decision rivals take, that is the dominant strategies. When one exists, the rational decision maker always follow the dominant strategy, predict rivals will follow the dominant strategies. Okay. So, with this we are closing our discussion on the concept of game theories. Why we have discussed game theory? In the context of oligopoly market, because oligopoly market is a market condition where there are few number of large sellers. So, what each firm is doing, that is clearly visible to everyone. That is why there is a chance for each player to observe others' activities and play accordingly. Therefore, this decision is a strategic decision making. And in strategic decision making context, no player cannot unilaterally take best decision without considering others. And that is why we discuss the concept of games, because that helps in deciding best decision in a strategic concept. Okay. So, once we are familiar with these concepts of game, then in our next class we will come back to oligopoly and discuss about the features of oligopoly market using the concepts of game theory. Thank you.